calculation, I'm using the denominators, as it were, to do the calculation. So first calculation, false if and only if true. So that's case 3. Look at the biconditional, and that turns out to be what? False. Okay. False. Okay. And now let's make this assumption that this is true. Well, so true if and only if false. So that's case 2. Under the biconditional, we see it's what? False. So it comes out false either way. So we know that this result is false. So let me just write false. Okay. False, then L. And L is unknown, so it could be true or it could be false. Let's calculate either way. So false, then true. So that's case 3. False, then true is true, right? Now let's assume that the L is false. False, then false is what? True. So it came out true either way, so we can say that that statement is true. Now notice what's crazy is we don't know what the value of n is. We don't know the value of any of the parts, but we can still deduce that it has to be true. Everybody understand that? So that makes us like super geniuses. Okay, that was number 5. Okay. I mean, having said that, you should be able to do this 3.2? Is this 3.2? Is that right? Yes. Okay. All right. Any questions about this so far? Everybody got it? Everybody knows where I'm getting these answers from when I do the calc? Yes?
Just about the true/false. So we assign that particular fraction whenever everything is unknown.
So I'm saying, well, first of all, let's just forget that negation is there. So I'm going to say n, I don't know whether it's true or false. So I'm going to say, I'm going to assume it's true in one case, and then I'm going to assume that it's false in the other case and see what happens, okay? And if I get the same result, then I know it doesn't matter what n was, right? If I get true on the first assumption, true on the second assumption, I just know it's going to be true. If I get false on the first assumption, false on the second, it doesn't matter, it's going to be false. Now, if I get it's true on one assumption, false on the other, well, it's unknown. That doesn't mean that we still can't go forward, right? That might be just part of it, and we end up doing with or true, and then the whole thing would be true over true, and we'd end up with true, right? If this is our final result, true over false, then we say it's unknown. Whenever the final result is true over false or false over true, you say, we don't know. Unknown. Okay. So, in section 3.3, we're given complex statements. And we do not know what the truth values are for the statement constants, but we want to know when the statement is true and when it is false. So what we have to do is we have to consider all the possible combinations of truth values for the statement constants, and then figure out what the truth value is for the entire statement. Okay? So let me show you how to do this. So suppose we have, this is number 1, and on 3.3, we have x if and only if y, then not y, then not x. And we got to figure out when this is true and when this is false. So we got to figure out all the possible combination of all of its statement constants. So our convention will be we list the statement constants in order, and there's only 2. There's x's and there's y's. We don't count not x's as a unique thing, okay? So we have x and y. We have 2 statement constants, okay? And there are 4 possibilities of combinations of truth values for 2 statement constants. Okay, so we're going to write them all out. They both could be true. The first one could be true, the second one could be false, or vice versa, or they could both be false. Line 1, line 2, line 3, line 4, these are better called interpretations. So what I'm going to do is I'm going to forget about all of these, and I'm going to assume that X is true and Y is true, and calculate this truth value, okay? And the main logical operator, the last calculation we would do would be the if-then. Does everybody see that? Because we have to work from inside the brackets first, and then that would be the last operation. So that's going to be the final truth value for this statement on this interpretation, on this line, okay? So let's do it. So X and Y are true. True if and only if true. Look over to line 1, go across the biconditional, and what do you see? True, okay? So we've done this part, now we need to go over here. Y on line 1 is true, so not Y is what? False. X is true, so not X is false, okay? Now I have to do this. False, then false. That's line 4. Go to the conditional, and what do you see the answer is? True. So now this is the answer, so I'm going to get rid of those. Those are what we needed to calculate this. So in the end, we have a true antecedent and a true consequence. So we're looking over for a case of true, true. That's line 1. Go over to the conditional, we see true, then true is what? True. Okay. So for interpretation 1, where we assume that X and Y are true, the whole statement is true. Okay? So now, on line 2, we're going to do the same process, except for here we're going to assume X is true, but Y is false. Okay? So true if and only if false. So that is line 2. And we look over the biconditional and we see the result is what? False. So I'm going to get rid of that. So the antecedent is false, but now we have to come over here. Y is false, so not Y is true. X is true, so not X is false. And now we have to do this. True, then false. That's line 2. Go over to the conditional, and that's the one time that the conditional is false. So we've calculated the consequent now. So now we have to do this. False, then false. That's line 4. False, then false. Go over to the conditional, and what do we see? True. So we've just figured out on line 2, this statement is true. Okay? Now we do the same kind of process for line 3, but this time X is false and Y is true. Okay? So X is true, Y is false. So we have true if and only if false. That's line 2, and we discovered that that is what? False. So we calculated the antecedent. Let's go over here. Y is true, so not Y is false. X is false, so not X is true. So now we have to do this conditional. False, then true. That's line 3. And if we look that up, we see it is true. Okay? So now I'm left with this calculation. False, then true. That's line 3, and it is what? True. Okay? So now we figured out for this interpretation, 3, where X is false and Y is true, the whole statement is true. Okay? All right. So now let's do this final one where we're assuming both of these are false. So we have false if and only if false. That's case 4. Look to the biconditional, and it's what? True. Correct. Okay, now over here, Y is false, so not Y would be true. X is false, so not X would be true. So now I need to do true, then true. That's line 1. Look over to the conditional, and we get what? So now we have this. True then true, that's case one again, conditional, we just did that, and the answer is what? True. So, this statement here, if X, if and only if Y, then, if not Y, then not X, is true. No matter, it's always true, it doesn't matter what the truth values of X and Y are. Everybody understand that? We have a special name for statements that always turn out to be true, okay? And these are called tautologies, or tautology, okay? So a statement that comes out, always comes out true, no matter what the truth value of its constituent parts are, that's called tautology, okay? Now, look, imagine that I put brackets around this thing, and then I put a negation here. So the last step would be to negate this true, negate this true, negate this true, negate that true. What would we end up with? All falses. Does everybody understand that? So if I changed it to not all this, we'd end up with all falses. In the case where it's always false, we say the statement is self-contradictory. The statement that's always false, okay? But statements generally aren't always true or always false, complex statements. Sometimes they're true in some places and false in others, and we have a name for statements like that. So this is always true. This is always false, and the last one where it's at least true once and false once, we say is contingent. Okay, some true, some false is contingent. Everybody understand that? So it depends on what the truth values are. Okay, that was number 1. Okay.